Oh no! Have you ever lost control on a slippery curve and found yourself driving head-on toward another car? Or have you ever had to turn the steering wheel quickly to avoid a car and almost lost control of the vehicle? These are the symptoms that occur when the capability of the tires has exceeded its limit, causing the vehicle to slip sideways. Once the vehicle spins out in this manner, it becomes exceedingly difficult for the driver to control the vehicle, and the possibility of getting into a serious accident is increased. The VSC, which stands for Vehicle Stability Control, is an epoch-making system that has been developed specifically to address such situations. It restrains the vehicle from unexpectedly slipping sideways in such conditions, thus contributing to the prevention of accidents. Some of the better-known systems that help prevent accidents are the ABS and Trc. When the vehicle is driven on a slippery surface, the ABS prevents the wheels from locking up during sudden braking. This helps to improve the vehicle's stability and handling performance. When the vehicle is starting off, the Trc prevents the wheels from freewheeling. As a result, this also helps to improve the vehicle's stability and handling performance. In other words, the ABS helps to improve the vehicle's stability during deceleration, while the Trc helps during acceleration. In addition to these efforts to improve the vehicle's stability, the objective of the VSC is to ensure stability during cornering. Thus, through mutual cooperation, the ABS, Trc, and VSC help to improve the vehicle's safety in all of its movements. Let's observe the effectiveness of the VSC during an actual test drive. On a slippery surface, when the driver turns the steering wheel quickly to avoid an oncoming car at a curve, the car without a VSC slips sideways. This greatly affects the vehicle's composure, making the driver to control the vehicle. However, the car that is equipped with a VSC system maintains its composure even under the same circumstances. As a result, it can safely complete the turn. When something appears suddenly ahead, the driver of the car without a VSC cannot steer the car properly and causes it to spin. However, the car with the VSC can properly avoid the object and safely resume its line of travel. During a lane change on a slippery surface, the car without a VSC slips sideways and its posture becomes unstable. However, the car with the VSC can complete the lane change in a stable manner. What is the mechanism of the VSC that restrains the vehicle from slipping sideways? First, let's find out what a lateral slip is. During cornering, the centrifugal force acts outward of the turn. The vehicle sustains this outward force through its tires, which grip the road and prevent the vehicle from jutting outward. However, as the vehicle's speed increases, so does the centrifugal force. At times, the centrifugal force overcomes the tire's gripping force. Then, the tires will not be able to withstand the outward force and will start to slip outward. This phenomenon is the lateral slip. The lateral slip could start with the vehicle's rear wheels or front wheels. If the rear wheels start to slip sideways, the vehicle tends to turn more inward than the curve that the driver had intended, causing the vehicle to eventually spin out. This state is similar to that of oversteering. On the other hand, if the front wheels start to slip sideways, it becomes more difficult for the vehicle to turn along the curve that the driver had intended, eventually causing the vehicle to bulge out of the curve. This state is similar to that of understeering. However, as this data indicates, the VVTi engine has successfully satisfied these seemingly conflicting demands. Now let's observe how the VVTi system accomplishes these feats. Here is a cutout of an ordinary engine. Since the cutout cannot be used to simulate the process of combustion, let's observe a demonstration through computer-generated graphics. First, the intake valve opens, the piston descends, and the air-fuel mixture is drawn into the cylinder. Then, the intake valve closes, and the piston ascends to compress the air-fuel mixture. The spark plug ignites the compressed air-fuel mixture. The air-fuel mixture quickly burns and expands, and this expansion force pushes the piston down. This movement is converted into the engine's drive force. The exhaust valve opens, and the piston ascends. The exhaust gases, which are the result of the combustion, are discharged outside of the cylinder. As we have learned from the processes described so far, the engine burns the air-fuel mixture to generate power. The timing in which the valves open and close As we have covered so far, the vehicle exhibits a completely different behavior, depending on whether the initial lateral slip occurs at the front or rear wheels. The VSC system continuously monitors the lateral slip conditions to restrain the vehicle's posture from changing due to a lateral slip. Let's observe the function of the VSC from the perspective of oversteering. Oversteering occurs when the rear wheels slip sideways, causing the vehicle to orient inward of the turn. Therefore, to counteract the inward orientation of the vehicle can be oriented outward, which results in restraining the oversteering. With the VSC system, the counteracting of the orientation of the vehicle is accomplished through throttle work and by applying the brakes of the four wheels independently. When the VSC system detects an oversteering condition, it restricts the throttle. As a result, the drive force at the rear wheels is reduced, enabling the rear wheels to recover their grip. At the same time, it applies the brake to the outer front wheel. Then, a force is created to orient the vehicle outward of the turn. This force counteracts the vehicle's movement to orient it inward of the turn. As a result, the vehicle can achieve the correct orientation to complete the turn. Then, why does the vehicle try to orient itself outward of the turn when the brake is applied at its outer front wheel? This principle can be observed through a simple experiment. Here, the two wheels that are joined by an axle are rolled down a slope. Without any intervention, the wheels roll straight down. However, if one of the wheels is pressed with a finger as if to apply a brake, the axle will turn in the direction in which the brake was applied. The same principle can be applied to a vehicle. If the brake is applied only at the outer front wheel, an outward force is created in the vehicle, around its center of gravity. This force is utilized by the VSC to maintain the vehicle's orientation in the correct direction of the turn. As a result, the oversteering condition is restrained, enabling the vehicle to complete the turn in a stable manner. Next, let's observe what happens when a vehicle understeers. During understeering, the front wheels slip sideways, causing the vehicle to orient itself outward of the turn. Therefore, by counteracting the outward movement by orienting the vehicle inward, the understeering can be restrained. When the VSC detects that the vehicle is about to understeer, it restricts the throttle to reduce the vehicle speed and to restore the grip force of the front wheels, and applies the brake of the inner rear wheel, which maintains the grip force. Then, similar to the principle discussed earlier, a force is created to orient the vehicle inward of the turn. This force counteracts the vehicle's movement to orient it outward of the turn. As a result, the vehicle can maintain the correct orientation while making the turn. Furthermore, while maintaining balance in the vehicle's posture, the system applies the brake on the outer rear wheel and the inner front wheel. As a result, the vehicle speed is reduced to enable the vehicle to maintain a stable turn. Therefore, by maintaining the correct orientation of the vehicle during the turn, the VSC restrains the understeering condition and enables the vehicle to complete the turn in a stable manner. Then, how does the VSC know that the vehicle that is making a turn is about to slip sideways? Let's observe this aspect from the perspective of the VSC system. The VSC system is constructed based on the ABS and TRC systems. It consists of 4 sections: the sensors, the electronic control unit, or ECU, actuators, and information. First of all, let's take a look at the sensors. There are 2 sensors located under the center console to detect the vehicle's movement. The yaw rate sensor detects the vehicle's rotation around its vertical axis, which is the yaw angle speed. The deceleration sensor detects the deceleration rate in the longitudinal and lateral directions at the vehicle's center of gravity. The steering angle sensor detects the driver's steering maneuvers. The speed sensors detect the rotational speed of each wheel. The throttle position sensor detects the opening angle of the throttle valve. The master cylinder pressure sensor detects the brake master cylinder pressure based on the operation of the brake pedal by the driver. The information that is sent by these sensors is calculated by the ECU. Then, the ECU sends commands to activate the actuator portion and the information portion. The actuator portion consists of the VSC hydraulic control unit, which regulates the hydraulic brake pressure that is applied to the wheels. And the throttle actuator that opens and closes the throttle valve. The information portion consists of the slip indicator light, which informs the driver that the vehicle is about to slip sideways. And the VSC warning buzzer that informs the driver of the same condition through sounds. During a turn, the ECU receives information from the speed sensors, yaw rate sensor, deceleration sensor, and steering angle sensor, and instantly calculates the condition that the vehicle is presently undergoing. The ECU commands the throttle actuator to restrict the engine output and commands the VSC hydraulic control unit to apply the brake of the outer front wheel to restrain the oversteering condition. At the same time, the ECU activates the slip indicator light and the VSC warning buzzer to alert the driver that the vehicle is undergoing a dangerous situation requiring the VSC to activate. On the other hand, when the ECU determines that the vehicle is undergoing an understeering condition, the ECU commands the throttle actuator to restrict the engine output and commands the VSC hydraulic control unit to apply the brakes in order to restrain the understeering condition. The brake is applied to the inner rear wheel and then to the outer rear wheel and the inner front wheel. At the same time, the ECU activates the slip indicator light and the VSC warning buzzer to alert the driver that the vehicle is undergoing a dangerous situation requiring the VSC to activate. In this manner, the VSC skillfully uses numerous sensors to correctly assess the current condition of the vehicle and carries out proper control to restore the vehicle to a stable driving condition. The ABS and TRC ensured the vehicle's safety in the longitudinal direction. Now the VSC expanded the vehicle's safety in the lateral direction. Keep in mind, however, the VSC is not a device that extends the limit of the vehicle's driving capability, nor does it mean that a vehicle that is equipped with the VSC can complete the turn more quickly. When the limit of the vehicle's capability is about to be exceeded, the VSC merely assists the driver in restoring the vehicle to a stable condition. The VSC has been developed with the concept that it expands the region in which the driver can avert dangerous conditions. Thus, the VSC will rarely activate, provided that normal safe driving practices are observed. It is important to understand that driving safely is of foremost importance, and that the VSC is a system that provides an added margin of safety.